Hello fellow chemists, in this video we're going to take a look at solutions in chemistry. So the first thing that we'll do is just take a look at what the basic definition of a solution is and then talk about some of the more important terms that you're going to need to understand when talking about solutions. So a solution is defined as a homogeneous mixture of two or more substances where each substance maintains its chemical identity. So the first thing we're going to talk about here is in solutions, they must be homogeneous. That means they must be evenly mixed throughout. An example of this is like a can of soda. If you open up a can of soda, pour it into two separate cups, take a sip from each of the cups, it should taste the same because everything that's dissolved in that soda is evenly mixed throughout. And then the only other term that tends to kind of give students a little bit of trouble here is they maintain their chemical identity. Now, an example of that is if I were to have a glass of water and then I were to dissolve some salt into it and then stir it up and the salt dissolves in the water, that's still salt. It didn't change into something else. And the way that you can prove that is if you boil all the water away in that cup, what'll be left is the granules of salt. So the salt maintained its chemical identity, even though it went from a solid into aqueous solution, dissolved in solution, it was still salt. So that's what it means by they maintain their chemical identity. So in a solution, you have two main components. You have the solute and the solvent. Now the solute is it's defined as the component in the solution that's in the smaller amount. And the solvent is defined as the component of the solution that's in the larger amount. Now, I always found it easier to remember them as the solute is what's being dissolved, and the solvent is what's doing the dissolving. Now, an example of this is if we have a glass of pure water, that is not a solution because it's not two or more substances, it's just H2O. But then if I take some salt, NaCl, and I dissolve that NaCl into the water. So you have the crystals and they dissolve into the water. That is now a solution. And the solvent for the solution is the water. That's what's doing the dissolving. And the solute for that solution is the NaCl. That's what's being dissolved. Now let's say I add something else into that solution. Let's say I add some sugar. So I take a little scoop of sugar and I stir that in and the sugar dissolves. Now you still have a solution. The solvent is still the water, but now you have two solutes. One solute is the sodium chloride and the other solute is the sugar. So that's what it means by a homogeneous mixture of two or more substances. You're always going to have just one solvent, but you could have more than one solute dissolved in that solvent. And the example that we saw here was with the sugar and the salt both being dissolved in. Now, another term that we want to be comfortable with when talking about solutions is solubility. And solubility is just the maximum amount of solute that you can get dissolved into the solvent under its given conditions. And the given conditions are the volume of the solvent that you have, and the temperature that you have, and the pressure that you have, because that will determine how much solute can get dissolved in. So things that can affect the solubility of a solution are temperature, and if you increase the temperature, you increase the solubility. Another factor is pressure. If you are dissolving a gas solute into a solution, and the easiest example of this would be a soda can. So they get the carbonation into the soda, that's a gas. and how much carbonation they can get into the soda is dependent upon the pressure above the liquid. If it's a higher pressure, it will push the carbonation into the soda. So if you increase the pressure above a solution, you can increase the amount of gas solute that is dissolved in that solution. So by increasing temperature or increasing pressure, you can increase the amount of solute that you can dissolve into your solution. And the amount of solute that you can dissolve in is called the solubility of that solution. Now, if you have what's called a saturated solution simply means no more solute can be dissolved. And an example of this is, let's say you're someone who likes sweet coffee in the morning. So you make your coffee and then you put in 10 scoops of sugar. And you keep stirring it and stirring it, and eventually you put in so much sugar that there's a layer of solid sugar crystals at the bottom of the coffee. Well, that would be a saturated solution. You have the maximum amount of solute possible in the solution. A saturated solution is easy to detect because you'll see solid particles floating around or sitting at the bottom of the solution. So if you have a solution and you don't see any solid particles floating around in it, it's not saturated. Then it would be called dilute. Dilute is when you can dissolve more solute. Now, you may take a taste of soda and say, well, that soda is not dilute. It has a very strong flavor. The soda probably is still dilute because you could probably get a little bit more sugar into it. So, what defines dilute is if you can get any more solute to dissolve in it, it's dilute. And you can physically see if something is saturated or dilute by looking to see is there any solid particulate floating around in the solution. If there is, then it's saturated. If there's not, then it's dilute. The last important term that we want to take a look at is an aqueous solution. And in an aqueous solution, water is the solvent. So in most solutions that you're going to be working with, water is going to be the solvent. But there are cases, especially when you get into organic chemistry, where the solvent, the liquid that's dissolving the other components, is not water. A couple of examples of non-aqueous solutions could be if you have benzene as your solvent, or you could have hexane as your solvent. These are both colorless liquids. They definitely have an odor to them other than water, but they're colorless liquids that you can dissolve other components in. Now, you can't drink them, they'll kill you, but those are examples of solvents that you could use that are not water-based. So that would not be an aqueous solution if something was dissolved in benzene or something was dissolved in hexane. All right, that's it for the basic definitions that you need to understand to be comfortable with solution chemistry. I hope you learned something, and I'll see you in the next video.